I think, especially connected to the roots of not just the lab here, but so much of what has inspired science in this region, which is kind of in many ways where the desert landscape, just looking out the window, it's so beautiful, seeing the lunar cacti, and they evolved down south in the tropics. And that's what we're going to learn more about tonight. But there's so much connection. I mean, that was the first slide there, Paul Martin, and the work that he did with the Southwest Center, directed by Jeff Bannister. Now we're so happy to be partnering with Jeff to make this series happen, and to really talk about, this really wild country to the south, that these deep barrancas, areas where we learned a little bit more about this tonight, where frost is not as important a factor, although very significantly, as we will learn, does play a role, but where plants kind of just grow free, and the land of the jaguar, the land of such interesting culture. So in this lecture series, we're hitting on different pieces of it. And tonight, we're so lucky to have Angelina Martínez from UNAM, based in Hermosillo, whose career really looks at nutrient cycling and the dynamics of the ecosystem and forest function. And really importantly, and maybe you talked a little bit about this, but there's a research station a bit further south than what we're talking about tonight called Chamela. And Helen's been instrumental in the long-term research. So very similar to the long-term research we have here at Tumamoc. In Chamela, this is one of the most important sites for understanding tropical dry forests. A year ago or so, there was a whole special issue done in the Journal of Forest Ecology with 12 or 14 more articles talking about how the forest functions in response to kind of intense impacts such as hurricanes. And this was completely organized by Hela. She has been at the center of running this whole network of researchers. So you have the opportunity tonight to hear from one of the true experts of tropical dry forests in Latin America and beyond. So I will also think it's important to mention that you guys are so nice for being here. They have so much going on in your lives this year, and this weekend you're celebrating the wedding of your son. So it's like such an honor that you came here to me. So welcome, thank you.
Thank you so much. Thank you everyone to be here, and thank you Anne and Ben for the invitation to be part of this lecture series tonight. I'm very happy and excited, and I thank you all for coming. So I wanted to dedicate this lecture to Paul Martin. He was such a kind, respectful, amazing man, always willing to share knowledge, always open to criticisms, to his new novel ideas about how the megafauna of the Pleistocene were extinct. But he also had a great love for Mexico. So thank you, Paul. We need you dearly. Well, I will, this talk is the life of the tropical dry forest, of a forest. Back in the early 80s, I started my first encounter with a tropical deciduous forest, which I will call TDF, to study litter decomposition when nobody really was interested in doing this kind of work. In the Chamela forest that Ben mentioned, in western Mexico and 19 degrees north of the equator. A decade later, together with Paul Martin and with Alberto Burques, my husband, and I, were in a TDF outpost, as David Jetman called it, in San Javier, in northern Mexico, in search of new information regarding the limit of distribution of tropical plant species at 28 degrees north in Sierra San Javier. Traveling with Paul was really an amazing experience, traveling from the coast to the Sierra Madre, and a learning privilege. One of the most fascinating trips during which geology, ecology, biology, climate ecology and evolutionary knowledge was at the core of our conversation. Paul, in his search of the secrets of the Sierra Madre, that he was very, very interested, flying in a little flight over the botanical world of Howard Scott Gentry, over the Sierra Madre, wrote in this book that the title is The Secret Forest by Chuck Bowden. He wrote, somewhere down below, the tropical trees of northern Mexico battled to hold their northern limit, advancing or retreating through the centuries while dwarfed by drought, pruned by frost, or buffeted by temperate competitors. And he said, the forest nobody knows and is disappearing. So in this book, Charles Bowden wrote, this book is a response of that lament. A region where desert and tropical, northern and southern, and continental and coastal species converge. Gentry, in his collections made in the 30s, reported in his book Rio Mayo Plants, published in 1942, over 1,200 species of vascular plants. 50 years later, this new book, revised and edited by Paul and David Jedman, Fishbane, Jenkins, Van Devender, and Rebecca Wilson, is an update of Gentry's book, reproduces the original text, and provides information for more than twice the species that first described by Gentry. Paul wrote, new species are being discovered in remote and unexplored canyons and on bare rock of cliffs. Complementing Bowden's book, written to increase awareness of the urgent need to protect the forests of the Alamos region in southern Sonora, this book, published in 2000, edited by Bob Robichaud and David Jedman, reviews its natural history, the ecology, diversity, and current threats to its integrity. And I recommend you the lecture. They wrote, despite the destruction in favor of African exotic bufflegrass, TDF endures needless northern limit, thanks to the roughness and foothills and barrancas of the Sierra Madre Occidental that shelters the tropical biota, and what Gentry called the habitat of the long spring dry season forest. Remind me tomorrow. Help! Pick a time, remind me tomorrow. I don't know what is this. The computer.
It's pretty bad finding your tech support.
Okay. So, what little is known about the secret life of the TDF. That means ecosystem dynamics, nutrient cycling, primary productivity, biotic interactions, vulnerability, and resilience to land use change and climate change. In a review and synthesis of the existing literature in 1995 worldwide, and in an update in 2011, we found only a handful of studies, despite of TDFs, have been used by humans for centuries. What are tropical dry forests? They comprise a broad spectrum of tropical and subtropical dry broadleaf forests, partially or completely deciduous, although evergreen species may be locally abundant, and succulent plants are also prominent. There are very large regional differences, so that the tropical dry forest goes by other names, like tropical deciduous forest, like short trees forest as Gentry called it, Caribbean, Hawaiian, Sinaloa, and monsoon forests, according with the composition of the species, they are called like that. In Spanish, according to our botanicals, it's called Bosque Tropical Caducifolio, as it called it by Rendosky, or Selva Baja Caducifolia, called it by Miranda and Hernandez. And local people in Sonora and in northern Sinaloa call it Monte Mojino, that it has during the dry season. Well, they are found all over the world, in all continents. As you can see in that map, the little black dots are where you can find TDF. They are always in frost-free areas where minimal temperature is below 17 degrees Celsius. The rainfall average varies from 250 to 2,000, and I think it's a little bit high that. But one important feature is seasonal drought, and I will talk about that later. One important issue is evaporation-precipitation ratio is about 1 to 2, and that is indicative of dry soils because evaporation is high. The soils are very variable. They can be poorly developed. In general, they are shallow and very sandy, but also you can find deep soils with high clay content and silt. And in general, they are less acidic than tropical rainforests because of the lack of rain. Well, currently, the extension in the whole, and there are different figures there, but it's about 1 million square kilometers. And this is 44% of the original cover compared to 900, according to a new paper that is in press by Jaramillo and Murray. And of all that, 67% is located in the neotropics, in this part of the world. One of the main climatic variables in these regions is precipitation amount. Now, TDFs are in the middle of a dry, wet precipitation gradient. Evergreen seasonal forests on moisture sites, and thorn, woodland, and cactus scrub at the other, in the drier end, and always in transition with other vegetation types. As you can see in this graph, in which is the frequency of major vegetation types versus precipitation, and this is an example of in South America in which dry forests are to the left of the graph in the drier area, and savannas are in the other side, because in savannas there are fire, and in the tropical dry forest there are no adaptations yet to fire, so they are apart. Another important feature of the weather is the strong seasonality. In this diagram, in the panel on the top, is the monthly precipitation in the chamela forest. And as you can see, there is, maybe you can distinguish, it says June to October is when we have the rainy season, and it's when we have the rains, and it's very variable. And there are gaps, and those gaps is the dry season. This seasonality triggers forest phenological changes, from deciduousness, completely leafless during the dry months, to a lush, evergreen aspect during the monsoon. Another attribute is the high variability of the summer rains during the monsoon that are indicated in the red line in the top of the panel, and see how variable they can be. And also there will be variation in the dry season precipitation, because we can have received a lot of rain as well, especially during the years of the El Niño events. In the Pacific coast of Mexico, during these Niño years, the precipitation during winter increased significantly. Okay. What about the conservation status of the TDF globally? Only 28% of the total of the 1 million square kilometers is protected, self-protected, mostly in South America. 76% of it is in South America. And according to this study of Miles, 91% is at risk from human activities and climate change. But this is part of what, in this study by Coextra published in Ecological Letters, they call it the global scale biome crisis. How is it going to deal and face this crisis? They found, and you can see in the panels in dark, is the protected area, the percentage of protected area by vegetation type, or by vegetation biome, or by biome. And on the right, you can see the percentage protected. And what they found was that 22% of the land area has been converted, and only 12% is protected. So the TDFs, as you can see in the upper part, indicated in red, is the highest percentage of habitat conversion and limited protection. So TDFs are high risk of biome-wide biodiversity loss, which is really worrying. There is a lot of interest in the ecological literature to understanding where are the carbon stocks, what is the carbon stored in the vegetation, and which is the role of the tropical dry forest in that. In this study by Begnell in 2012, TDF storage about 8.7 petagrams. And what does it mean? 8,700 millions of tons, roughly. And they are stored in the circles. You can see the amount that is stored in the region of the Americas, in Africa, and in Asia. The average loss rate in a recent paper, they say that in the last 30 years, we have lost at the rate of 1% per decade. And what are the implications of this loss? Is increasing the risk of biodiversity loss and ecological dysfunction with consequent impacts to human lives and economies, because we live from the ecosystem services that this ecosystem provides to humanity. Well, in Mexico, they are located mainly along the Pacific coast of Mexico. It is indicated in green color here in this map, and they cover approximately 14% of the country area. Protected in Mexico is only 2%, and is indicated in these arrows by Sierra San Javier at the north, our northern outpost. Here is Álamos, Sierra La Laguna in Baja California, Chamela and Manantlán in Jalisco, and here we have Sierra de Huatulco in Morelos State. And there are very important hotspots for TDF in the Rio and the Balsas Basin that are not protected. Floristically, they are really diverse. There are about 749 genera of phanerogams, sea plants, about 5,000 species in the whole of Mexico, and 65% of these woody species are endemic, so they just belong to this country, to this vegetation. There are strong floristic relationships with Central America and South America, and according to Judith Becerra, that is here with us today, the existence in Mexico dates at least from the early Cenozoic, 50 to 60 million years ago. TDF is the home of many, many threatened and endangered species of plants and animals. This is the list of the most important families that have more than 20 genera. But by far, the most important family are the legumes, the Fabaceae, with 85 genera and probably hundreds of species. And you can see there the pods of a coral bean tree and the flower of a cactus. So there is a remarkable diversity and endemism. 8% of the genera, which is a lot of species, are restricted to the limits of Mexico. Characteristic genera with more than 50 species are Bursera, like the elephant tree, Euphorbia, Ipomea, the morning glory, Euphorbia is the poinsettia species, and Mimosa, like the cactuo. 96 genera with arboreal species are dominant elements of the biomass in many Mexican TDF localities. Regarding the structure of the forest, you can see that photo here, and you will have a sense of how TDF looks like. You can see all growth forms: trees, herbs, shrubs, vines, parasites, epiphytes, and all of them are very abundant. There is a continuous closed canopy, more or less on average 8 to 12 meters tall, so they are very much shorter than the tropical rainforests. So probably that's because they are not so appealing as the tropical rainforest, because they are like shrubby. And there is an abundance of thin stems and multi-trunk trees, and that's a feature of their structure. This is one photo of Álamos at 27 degrees north. This is coastal line Sinaloa. I am moving to the south along the Pacific coast. This is Sinaloa, 24 degrees. Looks like Chamela. This is Chamela at 90 degrees north. And this is a photo of Huatulco, Oaxaca, that probably you have visited during the dry season at 16 degrees north. All of these forests have features in common. They have a seasonal climate. The 75% of the species are drought deciduous, lost their leaves during the dry season. Many species sprout as a response to disturbance or cutting, and that's a property for the regeneration of these forests. And these forests rarely experience fire. As I mentioned earlier, rainfall seasonality has a central role on soil water availability. And this drives the temporal pattern or biological activity, and we have measured those features. Photosynthesis, mineralization, decomposition, leaf production occurs mainly during the wet season in the monsoon. And nutrient resorption, leaf fall, litter accumulation, and flowering during the dry season. But also, these forests experience high unpredictability and variability of precipitation amount. In this short period, see how variable it can be. From years in which you will receive 440 millimeters, like in the desert, to years in which is over 3 more times, 1,200. We can have in a wet year, like the second there that in 1996, with a drought in the rainy season, and then extreme rainfall event in one single month that we can receive as much rain as in the whole year. Or there can be a very prolonged drought of 7 months without any rain at all. Or we can have rainfall in the dry season. So the force is like, what should we do? So this variability results in that the growing season can be as short as 3 months or as large as 7 months. So the species have to take decisions what is better to invest about carbon. So this has potential impact in the biochemical processes, like for example, phosphorus cycling and nitrogen cycling that is driving water a lot, and also soil organic matter. We have discovered that there are more accumulation of organic matter during the good years of good rains. And look at those 2 photos from the same spot in 2 different years, 1 year after the other one. So the first photo is good rains, so there are accumulation of water, runoff, infiltration, and in the second year was a dry year, and then there is no water around. You cannot see it. So that has implication, wide-ranging ecosystem effects, as it says there. Okay. Now, the hydroclimatic variability in western Mexico increased tremendously in the last 8 years because of the incidence of 2 hurricanes that struck the Pacific coast of Mexico, mainly the Chamela region, only 4 years apart. One of the hurricanes was Jova, or Jova as I call it, that struck the area in 2011. And we thought this is a disaster when we saw the damage that the forest, how the forest looked after the passage of Jova. But we were just working on that when a second hurricane, Hurricane Patricia, that according to the National Hurricane Center said Patricia could be the first category 5 in hit this part of Mexico in more than a half a century. And before Jova, 50 years ago, hurricane landing was very infrequent. And I've been working in the Chamela for 40 years and never saw that impact that these extreme events cause to the forest. So, pardon? So here you have in the left corner the path of the Hurricane Patricia. The little polygon inside is the Chamela-Cutzmala Biosphere Reserve that in the other side of the photo is surrounded, you can see the land, and it's surrounded by ejido land. So we have a lot of pressure on land use change. So Patricia just boom, and Jova as well, the eye wall pass over the reserve. And so in the photo to the left is before the hurricane. And the photo to the right, I don't know what happened, is the photo photo is the killing, the effect of that caused the hurricane, which killed thousands of trees as I have never seen in my entire career. So, before Jova, the canopy was dense, close, and tall, 7 meters tall, and the gap fraction that we measured was very, very low. After Jova, the forest decreased in height, was shorter, and open substantially, as you can see as well, opening to 0.37, the gap fraction. But after PATRICIA, the forest in the affected areas decreased further in height, it was shorter and more open. So which are the consequences of these changes in the light environment, in the evapotranspiration, in the decomposition processes? And that is something that we are investigating. Wind force from PATRICIA remove woody material from all canopy layers. You can see here one of my students in my lab measuring the amount of necromass, the amount of dead, coarse woody material that was fallen because of the hurricane. And what we found is that it was 3.5 higher the amount of debris that was in the forest compared to the pre-disturbance period. And now we are wondering what about risk of fire, because there is a lot of fuel accumulated on the floor, and with these extreme dry seasons or dry years, we are fearing of having fire in a system that there is no fire. Okay, alteration was not even throughout the landscape, but in the affected areas, we recorded that 23% of the biomass was lost, is on the floor. 61% of the trees were damaged, uprooted or limb, or broken branches, or broken the main trunk. 62% of the nest of the parrots were lost because the trees were fell down, so the parrots were like flying to the closest lagoon 30 kilometers to the north to bring food to their chicks. And 1/3 of the density of the diurnal raptors, like a list of 15 species, the density decreased compared to the outside of the radius of the maximum winds. And these are information published in this special issue that Ben mentioned earlier. Now I will move to the frost in northern Mexico, in the northern limit of distribution of the tropical deciduous forest. At this latitude, freezing temperatures are associated with cold frost. In February of 2011, before the hurricane Chamela, there was a severe frost with -3 to -17 degrees Celsius that lasted for 4 days. And that was enough time to kill a lot of trees. So there was a federal emergency in Mexico, and 71 municipalities in Sonora were declared an emergency. Severe damage was, of course, the cultivars were completely lost, and northern Sinaloa as well. But nobody paid attention to the native vegetation or to the forest, but we did it. And what we found is that there was widespread frost-induced tree mortality, as you would expect, because they are tropical plants, throughout the landscape. And these photos are from one of our study sites. And what happened is, as well, this event increased the necromass, the amount of dead trees, significantly, both in the mature and the secondary forest compared to the background mortality. So the implications of this is that the amount of carbon stored in the vegetation decreases, so there is a strong alteration in nutrient cycling and many other ecosystem processes that we are trying to figure it out what happened. What we found, and this paper was online today, that frost-induced tree mortality was modulated by topography. So luckily there are refugios areas where the forest was not killed. But in this piece of land that is 25 by 25 kilometers that we searched, we modeled the behavior of the frost, and we found that an elevation threshold below which the probability of occurrence of frost increase, that is in the lowlands. You can see in the photo that it goes like gray color, all of the forest forest was killed in the lowlands. So now we are investigating if the severe mortality, the severity of the mortality is related to the probability of damage, or if also the floristic composition matters, and if it is related to the severity of damage. What we found is this, that two species, the most important species of the secondary forest, that are the main legacy of land use change, because there's a process of regeneration of the forest, were severely affected by the frost. So they are highly vulnerable, with uncertain consequences for the successional pathway of these new forests. Okay. What is the resilience of these forests to these extreme events that we are just seeing now more often? We assess forest resilience, and that is the capacity of the forest to reach pre-disturbance levels. And in this graph, I am showing some calculations we made for the response of the forest after the hurricane Jova and Patricia. And as you can see there, after Jova is values, increasing values and higher than 1, and that means the forest is resilient. It could stand because it was recovering fast. But then after Patricia, you can see the productivity declined significantly, so we said, is it resilient or is it not resilient? So what happened is that after Jova, we have a few years in a row with precipitation well above average, particularly during the dry season, in which the precipitation was about 300% higher. So the hurricane brought a lot of water, and we had extraordinary rains, and so the forest was like, hey, because the forest is dry forest and responds to water. But then after Patricia, the canopy was severely damaged. This is the legacy of Jova, and we have precipitation below average. So the productivity declined. So our conclusion, before that, what we observed is that there was a low resistance. That means there were changes in adult ecological levels, from landscape to ecosystem to community and population. And this is indicated in the straight line, the black line in these models there. We found that there was a fast recovery, but the recovery was strongly controlled, as you may expect, by water availability immediately after the event, years after the event. So what we are thinking is that extreme dry years after disturbance will really threaten or may limit the resilience capacity to future extreme events. And sadly to say, we are waiting for more extreme events. That is now the norm under climate change. So all this information, as Spence mentioned, we put it together in a special issue published in Forest Ecology and Management, and they were very excited about it. The objective was to identify the mechanisms conferring short and long-term TDF resilience across ecological levels. I think this is one of the first collection of papers that works on these ideas of vulnerability and resilience for a TDF. We have still many gaps of knowledge, but there is a good progress here. So, under normal conditions, not without extreme events, the time taken for the forest to recover to the original forest after destruction or conversion to agricultural land or to pastures, you can see here in this circle, there to the right is the transformation, complete transformation of the land to pastures and agriculture that can last for 5 to 30 years more or less, depending on how the land is managed. When the land is abandoned, then there is a build-up of monospecific stands of these winolo and mauto species that were killed by the frost. So, if nothing is done to these sites, no more grazing and they are abandoned, then the process of succession continues of the recovery through the mechanisms that the forests have, that is recruitment and resprouting. So that new species from the nearby forest will establish, and is that we have, like at 9 o'clock, And if the cycle continues in 100 years, if we are lucky, without extreme events, we can have the forest back. Probably with not the same composition, but similar to the original. However, extreme events may cause extensive tree mortality in all of these stages across the successional path. And it resets the successional clock back to 0 and decreases the potential or the capacity of the TDF to act as a carbon sink. Is there any element of hope? Sorry for this news, but I think there should be some positive thoughts. So I think we must provide focus of attention on places, oases, places where the forest is doing fine or is not doing that bad, like these refuges, thank you, that might be used to enhance TDF conservation and restoration efforts. Based on good science and long-term monitoring is important, and it's particularly important communication with decision makers and with the society about the value of these ecosystems. Okay, to end this talk, some remarks. Tropical dry forests are biodiversity hotspots, carbon reservoirs, and they are vulnerable to land use and climate change. 44% of the original extension of the TDF remains intact worldwide, but still at risk from deforestation. Extreme events are transforming our landscapes, challenging ecosystem resilience to future disturbances. But we are making progress on better understanding the secret life of the TDF, which are the attributes conferring resistance and the capacity to recover for disturbance, man-made or natural disturbance. And as well, this has allowed us to improve our ability to address large-scale environmental problems, but also we need to talk transversally with many disciplines, with other colleagues, with people, with the campesinos, the people that are using the land, and with the people that take the decisions. Thank you.
So are tree plants that involve any kind of fire ecology that would be able to sustain a forest fire?
In the TDF?
Yes.
To my knowledge, no. Probably they will be selected, the ones under fire that will stand the fire will be selected, but not as in the prone fire communities that have made adaptations. This forest has adaptations throughout. They close the stomata, they drop the leaves, they have photosynthesis rates high when it is water, so they take advantage of the water on the soil with mycorrhizal, so but they have adaptation to fire but not to fire.
Well, you see, my concern is that what has happened after the hurricane is that you developed what coniferous forest that was called a layer of duff, inorganic, organic dry matter. Okay? When that catches fire, it has a tendency to scorch the soil underneath, so that there are no nutrients. So I think that's a really good concern.
This is the first time we have ever seen that amount of accumulation of hardwood debris in this forest. What we can see is that if there is a fire in the border of the forest, this is a forest and this is a pasture, the fire will not get in. So there is something in the winter, not enough fuel to set off fire, intense fire. So we have never seen inside the forest fire, but we don't know if this new addition of porosity material will do it. We have not reported yet, and this was in 2015, so there are no records of fire inside the reserves. And the subdeciduous forest is gone. It's gone because of the tallest trees that were pulled down by the hurricane.
You mentioned early on that there are a lot of resprouters in the forest, and as And that's often a mechanism for response to fire.
Uh-huh.
And clearly in this case, so what kinds of disturbances would that be? Do you think that's part of the response to?
Yes, the sprouting has been a lot, understanding the sprouting has received a lot of attention, no? Because there is a lot of mobility of carbon inside the plant to produce this new growth. And in these species in the tropical dry forest, they respond by the sprouting because during drought, they just have dieback.
Okay,
So they just drop
it's a
pieces,
drought
branches are lost, and then I keep alive, but lose some of my branches when they are sprout.
Okay.
Or also when they are cut. And many species are non-timber forest products are taken out from the forest. So they cut them and they produce lots of sprouts. Not all of them survive, but then there is a lot of mobilization of carbon inside the plant, and I don't know the mechanism. I'm not a physiologist, I would understand, I would like to understand those better, but yes.
So if part of it is a response to drought, how much of is it mortality of the entire plants due to the hurricanes, or is it snapping off branches so that resprouting might contribute to resilience?
A lot of the species sprout, many don't.
Okay.
The ones that sprout, they can sprout from the very base, even if the whole thing is die off completely, so it was a complete die-off, then we are recording all that sprouting from the different species after the frost.
Okay.
Very detailed census of all the species, and some plants can have 60 sprouts, and it's crazy, measuring everything. But then, yes, we want to record if the recovery comes from resprouting or from recruiting of new individuals.
How is baseline background mortality calibrated or measured? How do you track that?
It's a good question, because we have been studying this forest for decades. So in the past, we measure standing above biomass and the dead portion and the living portion. You can do it in two ways. Cutting plots and then recording everything, or using allometric equations. And we have done in the two ways. So, and we did it before these large disturbances. So we know the baseline of the background mortality that we call it, no? Did I answer it?
Yeah, thank you.
Patricia?
So you said that after Patricia, there was Patricia, right? That stood out from
After the
there was so much less precipitation that recovery was like nil. And then you also showed the graph where there's such various rainfall over the seasons and over the years. But what I didn't see, and I'm wondering if you've done it, or at least a comment, what is the general trend over time? Is there less rainfall over time that perhaps we're moving towards as we see these more extreme events? Over time, are we moving towards less rainfall and potentially less recovery? Is there a trend that you're seeing?
Well, there is just a recent paper published, and they found that there is a trend of increasing amount of precipitation during the dry season globally in these areas. And this is because of the extreme events, like the ones related with the Enso years. But it's so variable that it seems to be a trend of increasing precipitation in the dry season. But then, anyway, you can have drought after 2 years of good rains, and then the forest goes really crazy. So what is happening is that we don't have larger wet season, but more precipitation because of the intensity, the more intense rains.
So hard to predict long term and relationship to
Well, with this amount of variability is a challenge, because you have 2 very good years and 3 years with drought, again a lot of rain, and then a drought period during the drought spell during the wet season, and then rains outside the season. And when we have rains during the dry season, the productivity of chamela forest goes up. 23% higher. I have recorded that. So, how to predict it, I wish we could predict it.
Hello. I was recently in a wet tropical forest, and I was reminded by how much fungi there are. So many mushrooms on decomposing trunks, also live ones. Thinking about all the biomass and the die-off, what is the role, of course, the mycorrhizae, but what is the role of active fungi in the decomposition in the dry forest?
It is, I think it's high, but it's concentrated, of course, during the rainy season. And when I was doing the experiments in the forest, I could see the growth of the fungi in the leaves directly, making contact to the leaves. So there are a lot of microbial activity from fungi that decompose, and together with other decomposers like coleonemas and other microfauna. But I don't know the particular role of the microbials in the decomposition process. I'm not sure how fast it decomposes, and it decomposes very fast during the wet season and then stops. So the nutrient cycle is very quickly during the wet season. Yeah.
Can you talk a little about how people are thinking about these tropical deciduous forest spaces in terms of conservation? Is there some thought about protecting that as a totality, as an ecosystem, or just in a protected area, oases, as you said?
Which people?
Well, how are conservation biologists understanding conservation?
Well, I was just reading a paper yesterday that says protect our protected areas. Imagine, no? So now we have to concentrate on protecting the protected areas. Or how to face this biome crisis that was taken in this paper. No? So the ideal situation is to protect as many areas as you can, especially to connect the corridors, no? Or the fauna, because I'm just talking about the flora or the vegetation, but there is fauna related to this that happen to be the parrots, the jaguar, and many other species that move around. So the idea was to have more larger pieces of forest connected. And see the Chamela forest, the biosphere reserve is completely surrounded by the hydroland, completely surrounded. And according as well to a study, this land there in Chamela, the hydroland still keep like 50% of the original forest because there are larger kilos of 30,000 hectares, something like that. But I wish I could have the answer is yes, connect areas, no?
Are they ranching in Hitos, or are they having yucca, corn yuccas, or what's the mix of activities?
In the Chamela, crops and pastures and plantations and extraction of non-timber forest forests and growing cattle, which is like one of the Hidratarios was telling me, what is the sense of growing cattle in the wet season? They get fat, and then we have 6 months of dry season and the cattle lose weight. So it's like a prestige to have cows. Maybe you know that. It's prestige,
I have
not to
many.
have vacas, no? You have many vacas. So it's a prestige.
Is it, I actually have one more question about that. So, is that the single biggest threat, do you think, in terms of land transformation, scavenging, conversion to pasture?
Yes, deforestation. I think deforestation for pasture, yes. And agricultural land. Okay.
Last question.
Thank you.
So buffalo grass plays into that fire risk, doesn't it? Because I think that's what you were talking about in our class last year. So there's more risk of with buffalo grass planting for fire, right? It's part of this fire dynamic. So, and that's tied in, I guess, with the cattle ranching, turning into pasture land.
In the Chamela, there are not growing buffergrass. Guinea that we see here, but I think that the problem with buffergrass, as you can see here in the desert. It's larger than I think it is in the Chamela region or in the TDF. So, yes, they use slash and burn cultivation. That's one of the main threats, no? But there's no buffer grass for the ordinary, but I have not seen, like, as I mentioned earlier, fire from the grasslands that get into the forest. There's something that stops the fire getting deep into the forest. I don't know if now with that amount of material there. You want to say something?
I think it's the shadings that the lots to help compete with other grass. It's just not the same dynamics we have here.
Okay, that is in the desert.
Yeah.
So, I appreciate your patience and
Thank you.
listening to this talk.
Before you all go, I have one important announcement. Some of you may know that we are leading a trip down to Alamos. We leave on the 19th of October to the Reserva Monte Mojino. If you were with us last week, this is to the real heart of the Sierra Madre, some of the most beautiful protected areas. And it's true, I mean, everything Helen was just talking about, and we will see. We have an opening in the trip, did very recently, went a cancellation. We leave in a week and a half. A little short notice, but truly, this is a once in a lifetime opportunity to get to places you just don't get to otherwise. If you're interested, talk to me tonight or send me an email. All right. Sold. Thank you for coming. Join us next month for David Yevman, Jeff Bannister on the social experiments.